it turns red, we'll get started. E-text. Can somebody tell me what's the last thing? I believe it was discrete and continuous. Y'all tell me what's the last thing that's in your notes.
It was the discrete and continuous.
Thank you, Ms. Smith. I appreciate that.
My pleasure.
Okay, so discrete and continuous. Let me go to 1.1. Everybody should see my screen. And I hope you see it. And we're going to go, I don't know, do y'all have y'all's book open? Anybody tell me what page discrete is on? I'll get there eventually. There it is, page 7. Okay, now we talked about discrete. I'm going to turn this off, turn my camera off right now. And I'm going to turn the document cam on, and it's going to be right here. We talked about discrete and we talked about continuous. Somebody give me an example of discrete data. Somebody give me an example. That means I want y'all to say something.
Temperature.
4/2 fraction.
I'm sorry, discrete, what?
Like a 4/2 fraction.
4/2, that's discrete. How about how many eggs are in the refrigerator? How many eggs are in the refrigerator? Is that discrete or is that continuous?
Discrete.
Discrete, because what do you do with discrete data? Do you measure it or do you count it?
Count.
You count it. How about the average weight of everybody in the class?
It's continuous.
That's continuous, because what do you do with continuous? Do you count or do you measure?
Measure.
You measure. Anybody got a question on those two things? All right. Now, we're going to continue with 1.1, and we're going to talk about observational study versus an experiment. Observational study versus experiment. Now, with an observational study, you basically what? You watch. Now, I've got perv right there. Who walks around looking at people? Usually perverts or statisticians. So, you can either be a person walking around watching people, or you can be a observational scientist and observe versus be an experiment. Now, let me give you a scenario and you tell me if it's observational or if it's experimental. Now, what's the difference? Well, I'm going to kill two birds with one stone here and give you the definition while I'm giving you the example. Let's say that you are a scientist and you're studying sleep apnea. Sleep apnea is when you wake up in the middle of the night and you can't go back to sleep, or you feel like you're suffocating, or you stop breathing, or something to that effect. And you are in a room sleeping and somebody is watching you with a video camera, several video cameras, and you have hooked up to your heart and your brain waves, got those little things. What is that? Is that an experiment or is that observation?
Observation.
That is observation. Observation is when you are watching. But let's say that every time a person moves in that sleep apnea setting, I take a cattle prod and I shoot them in the side with the cattle prod and then send electricity through their body. Every time they move. What is that? Is that an observation or is that an experiment?
Experiment.
An experiment. When you interject yourself in some way, some form, whether it's a control thing or whether it is just a physical thing, you have changed it from a observation to an experiment. make sure you know the difference between the two, because those two right there are not only unit questions on a test, but these are standardized test questions. All right. What about an explanatory variable and a response variable? Variable context here is like a characteristic. Okay, an explanatory variable and a response variable. What happens if I take a cattle prod and I put it up against you and I mash the button? What are you going to do?
Go react to it.
You're going to convulse. You're going to react to it. Exactly. So what is the explanatory part of the experiment, and what is the responsive part of the experiment? Well, the cattle prod is the explanatory or explanatory, however you want to say it. The response is you jumping around. So with every experiment, there is an input and there's an output. And in your algebra courses, what did you call it? You called it X and Y, or you called it independent and dependent, or you called it domain and range. How many of you have ever seen the matrix?
I've seen it.
How about give me your virtual hand. How about the second matrix? How many of you have seen the second matrix? Or matrix 2? Okay, one person.
I don't know.
Really sad. Because now all y'all watching those cartoon movies now, right? All right. In the second matrix, Neo, Trinity, and what's his name? Morpheus walk into the French restaurant. Y'all, well, some of y'all don't know it. But the French restaurant owner, he says, I drink too much wine, I have to pee. And it's just funny the way he says it because he's talking with a French accent. Now, we're in the South, so I drink too much beer, I have to pee. All right? The meaning of this little saying is cause and what? Effect, Hubert. Yeah, that's right, class. Thank you for interacting. Cause and effect. Oh, cause and effect. If you do something in an experiment, there's going to be an effect.
Yeah.
All right. So make sure that you make this kind of association with an experiment with your mathematical background. Because the question that they will ask you on a test is what axes are independent and dependent goes with explanatory or response. And this kind of wraps it up right here. Any questions on those two things? Now, again, we're going over a lot of this. We're going over this because this is kind of like giving you a definitive or a defined or a definition background into statistics. It's not so you can go out and do all kinds of stuff. It's for you to be able to know the terms. What's compounding? Well, let's say that I work at Amstar 14, and I'm also a student at Tri-County Tech, and I've got to turn in a project. So I go and I look at Nicolas Cage movie Con Air, which was a good movie, and the only reason it was a good movie, it had, what's his name, Masanovich or Makovich or whatever his name is, Cyrus the Virus, and it had that other Italian, Basici, had him in it. You know, the guy with crooked teeth and weird eyes. Anyway, those two, they're very good actors. Nicolas Cage is not a good actor, but those two are. And you know, that movie was a pretty famous movie for Nicolas Cage. All right, and I would go to the Anderson Hospital, and I look at the suicide rates in Anderson for the last 6 months when the Nicolas Cage movie came to Anderson 6 months ago. And I have found mathematically that if you watch a Nicolas Cage movie, you're going to commit suicide. Yes or no?
No.
Does that have anything to do with each other?
No.
No. That's compounding. All right. Compounding is when you might think that something is correlating, or you may think that something is causing something to happen, but there is no way, even though they are bad, a Nicolas Cage movie is not going to make you commit suicide. Even though you've got two correlations that are very similar to each other. Everybody with me?
Mm-hmm.
So what is the opposite of compounding? Well, there's the lurking variable. Lurking. Okay, that means it's behind the shadows. Well, I'm going to cover that up. I shouldn't have showed you that. Does drowning deaths increase have anything to do with Rocky Mountain spotted fever cases increase? Do they have anything to do with each other? No, one's in the land, one's on water. But they have a lurking variable, and that lurking variable is what?
Not considered in the study.
What happens when June and July rolls around? What does everybody do?
It's in the pool.
Pool, pond, lake. What happens when June and July roll around and you don't go swimming? You might go hiking or fishing, and the fishing takes you through the woods to a lake or to a pond. You're out more. The lurking variable is hot weather months, you're out more. That's the lurking variable. Lurking variable is a third variable that binds the two together. Capiche?
Yeah.
Okay, I hope you understand. Nobody's saying anything. I don't understand where Miss Kidd and Miss Ritchie are. That's unusual. I thought Miss Kidd would be here. Where is she at? Hold on, I got to chat. Okay, hold on. Has the call been sent? I thought so. I thought she was there. Let's wait and get her in here. And I'm going to send a call to Miss Ritchie too, because it's very unusual for those two not to be here. Okay, so let's give them a chance to come in.
She might get off from work.
Okay, Miss Kidd is in here now, so y'all don't talk about her. All right. So now we're going to talk about a random sample and a systematic random sample and a simple random sample. Sorry, Miss Kidd. I wondered why you wasn't here. I told them that I thought you would be here. Is she talking? She ain't talking to us.
Can you hear me now?
Yeah. What's up?
I never got the
Why were
call.
you late? Huh?
I never got the call. Didn't come through. I've been sitting here waiting.
Well, we've been talking about you. So
I figured. I've been sitting here eating. I've been sitting here.
started?
I've been sitting here eating Mexican, waiting on you to call me. So
Oh my Lord. Oh, okay. I see how it is. I called everybody at one time. Everybody came in.
I don't know.
They said something about you being a loser in a ditch somewhere or something. I don't know.
Dead in a ditch, probably.
And yep, that's it. And I tried to call Miss Ritchie and she didn't come in. So, but we have got 10 now, 10 out of 12. Okay. And we are on random sample and simple. Can you see my screen, Miss Kidd?
Yes, sir.
All right. We are on random sample and simple random sample and systematic. Now, why did I pick these three out of the 4 or 5? Because these three are the most used. So I would like everybody to take a minute and write those down. You got the random sample, which is the most used. You got the simple random sample, which can be used, but usually it's not, because the systematic random sample is the one that everybody uses, or besides random sampler. Now, what is a random sample? Everybody has the same chance of getting picked. Now, why did I put the same chance or the same opportunity? Because if you are on a test, if you are taking a test, whether it's standardized or whether it's Math 120 Unit 1, you see the same or equal chance, that's going to be random sample. Each individual has the same or equal chance of being picked. And what is the famous example? Names in a what? Names in a fishbowl. If I give each one of you a Post-it note and tell you to write your first name, middle initial, and last name on it, fold it in half, and put it in a punch bowl or fish bowl or a hat, and I make them all, mix them up, jump around, excuse me. And then I pick one Post-it note out, that is a random sample. Okay? Please quit fixing your hair in class. Okay? All right. I'm the only one able to do that, but since my hair is perfect, I don't have to. All right. Simple random sample. What is a simple random sample? A simple random sample is this. I want you to write this down. Let's say instead of an individual group, I put Miss Kidd, Miss Smith, I'm sorry, Mr. Smith. I'm just going to say last names. All right, Kidd, Smith, and Spear, I call you Group A. And I put Group A on a piece of Post-it note, and I put it in the punch bowl. And then I put Group B is going to be Costanzo, Fry, and Wilson. And I put Group B on a Post-it note, and I put it in the fishbowl. And then Thompson, Mance, Hunia, and Gill, I put your names on a Post-it note and call you Group C. And then I put all three Post-it notes in a fishbowl, and I pick one. That is called a simple random sample. What is the difference between a random sample and a simple random sample?
You group them.
A simple random sample is usually a what? I'm pointing at it.
Group.
A group. Thank you, Miss Kidd, for the interaction.
You're welcome.
Y'all better be glad Miss Kidd comes to class, because this class would go by so slow.
I am the life of the party.
Because they wouldn't talk to me. Mr. Mance talks to me, but the rest of them don't. I think Miss Gill would talk to me if I pressure her. She will. And I got Miss Costanzo to tell me that she was descendant from Italy. So I'm doing good. And I believe if I taught record players and albums, I believe Mr. Fry would talk to me. Mm-hmm. But unless I bring up some of those things, they're not going to talk to me. I think it's something about they hate me or something. I think it's something like that.
So in other words, you're saying you really missed me.
Yes, but I'm not going to tell you that because you get a big head. All right, so systematic random sample. What is a systematic random sample? Now, a systematic random sample is the most used because it's valid and it saves what? Time and what?
Money.
Money. A systematic random sample is where you pick every 10th person that comes out of the door. You pick every person on the last column of the last of each page on the phone book. Every person that's on the bottom right corner of the page, you write that name down out of a phone book. Every 100th person that comes out of a movie theater. Okay, every nth person. That is called a systematic random sample, and that is used a great deal because it's a way to get a very open random sample but you don't have to do thousands of people. It's more what we call, I can't think of the word right now. Oh, cross-sectional. It's a cross-section. Okay, somebody has got their microphone on and they're making noise, and I'm not fussing, but try to not make noise if you're going to turn your, I can't tell because it's not lighting up. Okay, I don't know who it is, but it sounds like keys and things moving around on a desk. That's what it sounds like. So please help me out. All right, so now we are at the end of my little pieces of paper. So let's go to the book and let's see what else they bring up. So we've talked about okay, go ahead and write these down. Nominal, ordinal, interval, and ratio. Poor old ratio. Anybody, no, I'm not going to ask you if you're Andy Griffith fans, because hell, probably some of you don't even know who that is. But anyway, I can't tell you what I'm drinking, but I'm drinking something. I have to drink something.
Is
You don't write down the definition. Just write the word. Okay, nominal level, ordinal level, interval level, and ratio. Now, I want you to put, I'll do it with you. I'm going to go right here. I'm going to go ahead and just, if you don't mind, I'm going to go ahead and just do this. And I'll just rewrite nominal. Nominal is an umbrella. When I say it's an umbrella, it catches all. In other words, if I ask you, what is people at a race? You could say nominal, and then you would say ordinal. What about the people, males and females in the class? That would be nominal. And really, it'd be ordinal because it's in order of male and female. But you could actually argue about the ordinal. But nominal, if you count something, it's going to be nominal and something else. Nominal is everything. No matter what you count, it is going to be nominal. But in some cases, you're going to have nominal and ordinal. Now, ordinal is real easy to remember because ordinal is representing what? Order.
Order.
Meaning, I'm going to say rank. Anything in ranked order or in first, second, or third, usually we're talking about a race, like first, second, and third. Anything, how about grades? Are grades in order? Yes. A, B, C, D, E, and F. I watched a good TV show last night. Just started. It was called Resident Alien. Have you anybody seen that?
So
It was cute. It was a cute show. It comes on every week. It just started. I think it's on Sci-Fi. And it's not a sci-fi. It's not, okay, let me go back. It's not a sci-fi cheesy movie. It's not anything like that. Because sci-fi movies are fun to watch because the computer graphics and the acting is so terrible. It's like watching a soap opera. It's just you watch it because you want to see how terrible it is. Well, this is a good show. You might want to look it up. It's called Resident Alien, and it's pretty funny. Okay. Okay. Nobody's going to interact with me tonight, so Miss Kid's drinking rum and Coke, so we can forget her in about another 30 minutes.
I like it.
run to
All right. Interval. Interval means that the 0 does not mean absence of quality. I mean, a quantity. Let me ask you something. Your birthday. If you say you're 0 years old, I didn't spell ordinal correctly. It's with an I. Ordinal. Oh, now you're going to tell me after I done figured it out. Just like a wife. All right. Let me change that. That's with an I. Ordinal. I suck. Ordinal. Okay. The next one is interval. Interval and ratio. Interval and ratio. Okay, I'm going to cut some of y'all off if I keep hearing that it's clicking. I'm getting tired of it now. All right, ordinal, and I said interval and ratio. Interval would be, I think, a good one is age. Why? If you're 0 days old, 0 months old, does that mean you disappear? Does that mean does not exist?
No.
No. 0 months old means that you've just been born. Okay? So 0 does not carry a meaning of non-existent. Does everybody understand that? So I consider this interval. But there are some books that say this is ratio. I don't agree with that. Ratio, a good one for ratio is temperature. 0 degrees meaning that this thing old cold, but meaning that it's 0 degrees. That means there's an absence of heat. Now, these are SAT questions. I really do not test you on these, but make sure you know them, because you might see them in your homework and you might see them on a standardized test. And they're real easy. Nominal catches everything. Ordinal, anything with order or rank. Interval, 0 does not hold the absence. Here, ratio, 0 does hold absence. 0 here, 0 months old does not mean that you evaporate. It means that, that's just, that doesn't mean absence. This does. And they give you some examples on the next page.
Would interval could you also use like years or months, because years and months, they repeat themselves every year, so you've got intervals, so they're kind of repetitive?
I think you could, you would do, ordinal would be months.
Okay.
Because they're in a certain order.
Okay.
Here's examples right here. I want you to write them down. Gender is nominal. Temperature is ratio. Interval. I'm sorry. Did I say ratio or interval? I have them pass backwards. I'm sorry. To interval is, dang, I hate when I do that. Interval is temperature. And ratio, what's a good example of ratio? Let's see. I thought temperature was, hold on a second. Let me find ratio. Where does it say ratio? Ordinal. There it is. Number of days that you actually study, or whatever. Number of days in the past week that a college student studied. Okay, so that would be number of days. Sorry about that. Number of days studied. And temperature would be interval. I made a mistake there. Okay, so there's 4 good examples. Those are test questions right there. Gender is nominal. Temperature is ratio. I mean interval. Is interval. Number of days during the week is ratio. And letter grade would be ordinal. Now, I can tell you right now, most of the time a test is going to ask you an ordinal question. Usually, every test question I've seen has always been ordinal. I don't know if it's just because that's the easiest one or it's the one that, you know, people get correct, or I don't know. All right. But again, I'm not going to test you too much on that. But I know those are on standardized tests. And that's 1.1. That's it. So let's move on to 1.2. 1.2. I'm getting there. Give me a chance. Give me a few seconds. Here we go. And we talked about this a while ago. I must have had my sheets out of order. Explanatory is your x-axis. I'm going to pull that back for Miss Kidd, because even though I want her to fail, I don't want her to be behind. So let me find that. Oh, come on. Here it is. You know what's amazing? And I think this is so cool. Where I'm sitting right now, it's like pitch black dark. And if you look at my video, see, I'm like sitting in the dark. But this overhead, I meant this document cam is like, I don't know how it's picking up this, because I can barely see these words. I'm having to look on my screen to see them, because I turn this light on with a ceiling fan. Oh my gosh, it'll look like a greenhouse in here. It'd be so bright. So anyway, I just think it's interesting that you can actually see this, and it's almost dark in here. Anyway, I want you to write these down, Miss Kidd. I don't know if you were in here when we went over this, but this is important. An observational study is when somebody is just watching. An experiment is when you don't just watch, you actually interject or interact with the observational, and it turns into an experiment. And cause and effect, explanatory versus responsive. We talked about electrocution. If I electrocute you with a cattle prod, you're going to jump. Explanatory would be electricity. Response would be jump. In math, it's called independent and dependent. X-axis, Y-axis. Water makes ice. Input, output, domain, range. In any situation in statistics or probability, there is something that makes you do something. All right. You know, if you go to a, don't you do anything on, hold on a second. All right. Oh, sorry about that. Now, what was I talking about?
Cattle prod, electricity.
Cattle prod, yeah. If I zap you with a cattle prod, you're going to jump. And in an experiment, you have to have something like that. Now, in observational, you don't have to have a cause and effect because you're just watching. So if I start, you know, following my students around and watching them, you know, 24 hours a day, that's called an observational study. It's also called stalking. Okay, but if the person gives you permission to do the stalking and you go to a lab like sleep apnea, you're familiar, Miss Kidd, with sleep apnea, right? And you just film somebody sleeping, that's an observational study. Now, if I start electrocuting that person whenever that person moves, that's an experiment. All right, so we went over that again from Miss Kidd because I had it out of order.
Did
which I'm
you
sorry
write it?
about that.
I can't see, right at the bottom of the paper.
Independent and dependent.
Aha, there we go.
She just wants me
Independent.
to turn on these lights. That's what she wants. She's just being difficult.
Mm-hmm. Okay, I got it.
All right. So let's move on. And again, I'm just picking out the stuff that's important. If I skip it, then chances are you don't need it. There it is right there. There it is, observational. I'm not going to worry about designed experiment. Confounding. We talked about confounding, and I'm sorry I got this out of order. In confounding, Miss Kidd, we talked about working at a movie theater and doing the statistics. But are you familiar with Con Air with Nicolas Cage?
Yes.
Okay. And you do the ticket sales for Con Air and you get a line like this. And then you go and pull the suicide rates in Anderson at this time and you get a line like this. Then you can mathematically say that watching a Nicolas Cage movie will give you suicidal thoughts. No, that's confounded, meaning that there's nothing between these two correlations. Whereas if you do a lurking variable, what's in common with a drowning deaths increasing and Rocky Mountain spotted fever? What's in common with those two things?
There isn't anything in common. Those are things that are not thought of.
Yeah, they are. A lurking variable is something that you don't see. You just proved it. You don't see it.
Okay.
Hot water. Hot weather months.
Hot weather month. Okay.
So
no.
that's what we're talking about there with confounded and lurking. Well, you'll see that in the homework, but you won't see it.
Yeah, I saw that when I did it.
Yeah, you won't see that, and I doubt very seriously. You might see it on a standardized test. I won't test you on it, but you might see it on the homework.
Well, what they had put on the homework was kind of like a similar question of, does having a beanbag chair in your bedroom, is it a cause of, is it the cause of most Americans being overweight, or is it just something that
Well, it could be, because if you spend a lot of time in a beanbag chair, then you're going to be lounging, and that means you're going to be in the house a lot.
Right.
And if you're in the house a lot, that means you're not active outside.
Correct.
So there could be a correlation there.
Right. And that's basically what the questions were asking on the homework was, is this the cause of obesity, or is it just something that could possibly?
Yeah. Mm-hmm. Okay, I need you to write down, even though most of you know it, what is retro? When you hear the word retro, what do you think?
Old and cool.
Back in the day. Yes, old, back in time. So you need to write down retrospective. A retrospective study is something that looks in the past, back in time. Cross-sectional studies, a specific point in time. Now that's the difference between the two. Back in time and any point in time.
Okay.
Now, if you retrospective, here's an example. we might match individuals who smoke with those who do not. When we say match individuals, we mean that we do not, that we would like the individuals in the study to be as similar as possible. And we look in the past 25 years versus now. Now would be a certain point in time or in 1957, not since 1957. Okay, there's a difference between 1957 and since 1957. That's the difference between case control, cross-sectional is in, put an in, I-N in quotation marks, in 1957. Retro would be since 1957. And we're going to move on. Those are SAT questions, standardized test questions, and homework. Okay, write down census. The reason you need to write down census is because everybody that graduates high school or college should know what a dang census is. Okay, and I'm gonna make sure I'm not gonna test you on it, but you need to know what census is. A count every 10 years. Here in America is 10 years. I don't know. And census, centus in the Greek means what? Or Latin means what? 100. Centus, C-E-N-T-U-S, centus. Oh, shut up, Hubert. They don't care. Census. That's where we get century, centennial, cent, census. Next. That's not a standardized test question. That's a don't show you ignorance in the real world question. And that's 1.2. Oh, we're making good time. Hopefully get to 1.4. Usually I get to 1.4 the first day when I do this. So, okay, we're in 1.4. I've already discussed random and simple random. I think, Miss Kidd, you came in on that, didn't you?
Yes, sir.
Okay. I'm looking to make sure I haven't skipped anything. Hold on. Random sample is the process using chance to select individual. Okay, that really is not a good definition because it doesn't have each individual has equal chance. Each individual has equal chance. All right, simple random sample. I already told you what that was. That's when you have more of a group. Okay. And systematic should be next. If we ever find it. Good gracious. Okay, I guess they're not going to do systematic. My gosh, you're telling me that one section is only covering two? No, that can't be true. You're telling me that one section covers 2 words?
No, didn't you say random surveys in every 10th, saving time and money for systematic?
No. Random and simple random. They spent a whole section on 2 words. Look at this. Random sample.
Now you see why I was so confused. Because I was like, everything sounds exactly the same.
Yeah, random sample is individual. Simple random sample is with a group. But why did they just, you're going to see, because in 1.4, they're going to say systematic. Why did they do that? Okay, I'm sorry. I just never seen that in this book before. Usually I just do it without the book and I just go. Now you're going to see probably in 1.4, you're going to see systematic. And if they did do that, that is really, really, I don't know what you call it. I don't like to use the word stupid, but it is stupid to have just 2 words in one section. Y'all understand what I'm talking about? Miss Kidd is talking about us. That's what she's doing. Watch
Yeah,
her.
I told my
She's
boyfriend
talking about us.
you're really funny.
Okay. I'm looking, I'm waiting. I'm sorry. Oh my gosh. Here's 1.4, systematic. It is obtained by selecting every nth individual. So every 7th person. A good example would be if I want a survey of people at the Anderson campus that drink tea versus water. Then I'll sit outside the front door of Anderson campus and I ask every 10th person that comes out. And I do that all day. Not only can you figure how many people you surveyed, but you know you actually got every 10th person. Because if you got 40 people, how many people walked out of that door that day? 40 times 10 is what? 400.
400.
That's right. So you know that big N is 400 because you did every 10th person. And you got 40 people. Hold on just a minute. All right. So systematic sample, I'm not going to go over that. We've already went over it. That's a good SAT word, standardized test word, and homework. I don't think I'm going to test you on that. Don't worry, we got plenty to test you on in chapter 3. That's all I care about. Because I'm going to make sure that you fail. Oh my gosh. Okay, cluster sample. Cluster sample is obtained by selecting all individuals within a randomly selected collection or group of individuals. Okay, and it gives you an example right here. Suppose a school administrator wants to learn the characteristics of students enrolled in online classes. Rather than obtaining a simple random sample based on the frame of the students enrolled in online classes, the administrator could treat each online class as a cluster and then obtain a simple random sample of these clusters. The administrator would then survey all the students in the selected cluster. This reduces the number of classes that get surveyed. So he's just going to, instead of, let's say he has 10 classes of 30 people, that's 300. All right. Instead of doing all 300 people, he just does 3 and just surveys the whole class. That's like 90 people. Okay. So that's a cluster. It's not used a lot compared to the first 3 that I told you. The first 3 is the ones that use the most. Next, where is stratified? A convenience sample. Okay, I want you to write this one down. Convenience sample is the least used. And it's also the most inaccurate. Convenience sample is the least accurate and it's the least used.
Okay.
What's your question, Ms. Kidd?
Which one? What did you say now? I'm sorry.
Convenience.
It's
Convenience is the least used and it's the most inaccurate. Suppose I work at a rock station. 80s rock is all I play. And I work at a rock station and I only play 80s music from 5 o'clock in the afternoon to 12 o'clock at night. And I have a project coming up in my probability and statistics course, and I've got to get some data. So I say on the speakers, I say on the air, I said, I need you to call in right now if you like rock music versus country music. Now, why is that a convenient sample?
Because everybody can call in. It's open.
Okay, you are a DJ and you're not reaching just 5 people. You're reaching like 5,000 or maybe 50,000, depending on the city. So that's convenient. But what else is also convenient? Why is it inaccurate?
Because the people listening to your station.
Go ahead, Miss Honey. You started first. I don't know who else started, but
The people listening to your station most likely aren't going to be country music fans.
exactly, because they're listening to your station, which is what? 80s rock. Now, the reason I say 80s rock is besides 60s rock, there's only 2 rocks, 60s and 80s rock. And you could argue that 50s was, you know, in there too, but there's no other than those 3. Anyway, I'm gonna let y'all are not gonna argue about it because y'all don't want to interact with me. So 80s rock is hard to beat. I'm sorry, it is.
I agree.
It is. I don't care. It is. And you can forget 90s. And I don't even think in 2000s we have rock or country. I don't know what the hell we have now. I don't know. All right.
No, that's a hick hop.
What'd you say?
That's hick hop. That's not country. Country is
I don't
Conway
know what we
Twitty.
have now.
Country is Conway Twitty, Merle Haggard.
Yeah. All the way up until, I would say, Brad Paisley.
Yeah.
And
George
that's
Strait.
all country. But I don't know what they have now. I mean, they say it's country, but it looks like a bunch of, I ain't gonna say nothing.
Men in skinny
All right.
jeans.
Stratified. Here we go. I don't know where stratified went. Can somebody tell me where stratified is? Because I didn't see it.
That might be 1.4.
It's where?
I saw it somewhere.
Well, I haven't seen it yet. It's on the back page, but it's not in a definition. Okay, wait a minute. I think I found it. It's at the bottom of page 28, I think.
1.4.
Yeah. Bottom of page 28. They skipped it. I mean, it's on 1.4. A stratified is when you go in and you group inside of a group. Let's say that I go into a voting precinct, which is a group out of 46 voting precincts in Anderson. I go and grab one precinct and I divide it into male and female. That is called stratified. Okay. Now, the best way to, they give you pictures on this last page over here. And there we go. Simple random sample. Each individual has out of this group right here, you make a subgroup. Out of this population, you make a group. That's a simple random sample. Stratified is where you break it up into 2 groups. This into 2 groups, male and female, or people above 40, people below 40. And then you break that up into male and female. Okay, that's stratified. Cluster is like the class. Instead of surveying 10 online classes, I just survey 3 out of 10. Systematic is every nth person. You're going to need to get you a comfortable chair, Miss Kidd.
I know.
And that's 1.4. Now let's jump over into 2.1. Has anybody got a book? Tell me what number 2.1 is on, or I can just look it up. 2.1 is on page
61.
61.
Yeah, 61.
Does anybody know what a frequency distribution is? A frequency distribution is a fancy way of saying table. Not the table you eat on, but a table. Here is a frequency distribution. Blondes, brunettes, and redheads. 4, 5, 1. That is a frequency distribution. Now, before you were enlightened in this class, you called it a table. Did you not? Or a chart. But now you can't call it that because now you're sophisticated and you got to call it a frequency distribution. Your category is over here. Your head count is over here. But you can't call it a head count. You got to call it a frequency. Frequency. And it's usually called F for frequency. Now, most of y'all know what a head count is. That's how many people have blonde hair, how many people have brown hair, and how many people have red hair. Now, we all know that brown eyes and brown-haired people is the best, okay? So we know that, and it's the most common. I bet you didn't know that. Which color eyes, and I think I asked y'all this the other night, represents 2% of the population?
Green.
Green. So if you have green eyes, that means you're in the minority. If you have brown eyes, you're in the majority. And if you have blue eyes, you're in the middle. Okay? So I'm going to draw another frequency distribution over here. And I want you to tell me the difference between the two.
You're doing an age limit.
You got ages, that's correct, it's ages. But
You're
tell
counting.
me the difference between the two frequency distributions. This is a test question. This is not only a test question, it is a standardized test question. So what's the difference? I'll tell you this, the answers start with Q.
Quantitative and qualitative.
Okay, which one's which?
So the one on the left is quantitative and the one on the right is qualitative because you can count it.
Bass-backwards. I think you meant the bass-backwards.
Yeah.
Flip-flop. Okay, I know what you meant. This one is qualitative. This is what we call a qualitative frequency distribution. And you have to talk sophisticated when you talk about a frequency distribution. Can you do that down in Ivor? Can you talk sophisticated down in Ivor?
Yes, we sure can.
Oh, I'm sorry. That's South Ivor I'm talking about. South
Hey,
Ivor.
I'm not in LA. I am not in LA.
All right. And this is quantitative. Now, unless you're from Star and Iva, you don't know what I'm talking about South Iva. But anyway, that's called Lounsville. All right. Down there, they don't have a, you know why they don't have a, you know why they, in South Iva and Lounsville, you know why they don't have a crime rate down there? Because if you break in somebody's house, you're not only going to get shot, you're going to get shot and hung.
You don't go to jail.
Exactly. You don't go to jail. You get shot and hung. Kind of like, anybody ever heard of Tomasi Salem?
Mm-hmm.
No.
Same thing. Pickens? Yeah. No, if I was starving and I didn't have a car and I was starving, I would eat a squirrel before I'd break into somebody's house up there. Because if you're in South Iva and Lounsville or Tomasi Salem, you break into somebody's house, if you're starving, you're going to be shot and hung and probably burned. All right. So anyway, I got family that lives in South Iva, so I'm making fun of them. All right. So anyway, that's qualitative and quantitative. Make sure you make this definition because this is a test question. Now, we're going to talk about a few things. Let me looking at the time. We got about 10 minutes. I'm not going to talk about this too much because what can we not do with this? We can't do anything mathematical. Why? What's the average of blondes, brunettes, and redheads? You can't. But you can do something with this one. We can do math with a quantitative frequency distribution. Why? Because we can get some things over here that we need.
You can add up like the population of the class and everything.
Well, yeah, the population, you just add this side up, and that's N. N is equal to 7, 10. So N is equal to 10. And that's the population of the whole group. You just add them up. But we can get something on the left side too. And we're going to go through that right quick before quitting time. So I'm going to rewrite this table. I'm sorry. Frequency distribution. I'm going to rewrite it on the next page. And we're going to get some information from it. So here we go. And class, because it's quantitative, you have classes. 20 to 24, 25 to 29, 30 to 34, and 35 to 39. And 4, 3, 2, 1. First thing you want to get is N. N is equal to the total. So you add the head count up. Add head count. And you get 10. Okay, so that's the first thing we do. And these are test questions. They will ask you to find these things on a test, in my test, and the homework. What is N? And you add all of them up. Second thing you do is I want you to find what we call the class width. How do you find the class width? Well, I'm going to take my highlighter out. I've got to hurry because I only got like 8 minutes. And some of y'all are going to start convulsing. On the left side, these guys right here, these are called lower class limits. Lower class limits. And on the right-hand side of your classes, and we're going to do a pink highlighter. If this is called the lower class limits, what do you think this is called?
Upper class limits.
I tell you what, I can't do anything with y'all. Y'all are on the ball.
And your width is how far it is between your lower class and your upper class.
Yeah, and you got to be careful how you get it. I tell students to go vertical. Okay,
Right.
I tell students
count
to
this.
find your class width, you go vertical. Do not go horizontal, because what is 24 minus 20?
4.
And 24 and 4 is not the class width. So you cannot go horizontal. Do not go horizontal. Go vertical. That means take a corresponding upper class limit and minus a corresponding lower class limit. So what is a corresponding? That means two that are next to each other. So I'm going to take one. I'm going to take 25, and I'm going to minus 20. And what's 25 minus 20?
25.
5 is your class width. Now, let's go through the thing. What's 39 minus 34?
5.
What's 35 minus 30?
5.
5.
What's 30 minus 25?
5.
If you do corresponding lower class limit and subtract it from the corresponding upper class limit, you will get the class width. A lot of people just pick these two right here. Now, Miss Kidd, being the rebel that she is, she may pick these two right here on every single problem. It doesn't matter. You're going to get the correct answer if you subtract the corresponding lower class limit from the corresponding upper class limit. If you go across, what's 34 minus 30? 4. And you're going to get the wrong answer. Now, how do you do it horizontally? Do you remember in junior and elementary school, do you remember when you counted on your fingers?
20 to 24.
Do you remember when you counted on your fingers?
Yes.
That's what you do. I want you to count on your fingers from 20 to 24. 20, 21, 22, 23, 24. How many fingers?
5.
So if you go horizontally, you've got to count on your fingers. If you go vertical, you subtract. Did you get that? Did everybody get that? All right, I'm going to do the midpoint. Why is the midpoint important? Because the midpoint is the thing that you can use in your calculations. The midpoint is used in calculating your mean and your standard deviation for a frequency distribution. Now, we're not going to do that in here. Okay, we could if y'all want to, but it is a nasty formula, and I choose not to do it because you don't need to know it. But I do want you to be able to find the midpoint. How do you find the midpoint? Well, it's real simple. You take any lower class limit and you add it to the corresponding upper class limit, and you divide by 2. So I'm going to do the first one. That's what we always do, the first one. And that's going to be 20 plus 24 divided by 2. And that's going to be 44 divided by 2, which is what?
22.
Which is 22. So the midpoint, I'm going to go up here and add another column. I'm going to add it in a color. Let's go with orange. I'm going to add another column up here. And the midpoint is usually called X. And I'm going to put an X right here in parentheses. Because when you're talking about statistics and you're doing, I didn't say X bar, I said X. Then the midpoint here is 20. Now I'm going to show you a shortcut I learned in the war. Sorry, 22. You could calculate each one of these, or you could just calculate the first one and add the class width. What's 22 plus 5? 27, Hubert.
What's that?
What's 27 plus 5?
32,
What's 32 plus 5?
37.
And that's how you do those three things. So we have found N, we have found the class width, and we have found the
Midpoint.
midpoint.
Hey, Terrell, go ahead and record Entertainment Tonight with Tiffany.
What was that? What did they say?
Sound like somebody was in trouble.
Oh. Mr. Mance, were you in trouble?
No, just tell me of course something.
Oh. Okay. Y'all good?
Mm-hmm.
Okay. I'm going to look at now we lost somebody. We lost 2 people, didn't we? Wasn't there, how many people did we have? 12?
Yeah, something like that.
Something about that.
Who did we lose? Thompson. We lost Thompson, I believe. Okay, let me look at I'm going to stop the presentation and I'm going to stop the recording. And I'm going to look